Okay, here's an example where we can use what we know about vector diagrams and kinematic equations. We have a park worker who's walking around picking up litter. It takes him 20 minutes to collect in 6 major areas of the park. He starts at the entrance and walks 15 meters east, picks up trash, then continues 12 meters south, then 6 meters west, 8 meters south, 10 meters east, and then ends up 5 meters north. What was the park worker's average velocity during the trash pickup? This might look scary and overwhelming, but really it can be broken down into several simple basic steps. The first thing is we know that we're looking for velocity. And we know we're looking for an average velocity. What do we know about average velocity? Well, we know that the average velocity is equal to your total displacement over your total time. Well, do I have enough information to do this? I have the time, 20 minutes. I can find his displacement and then therefore calculate his average velocity. So the biggest thing here is to work on finding his displacement. We're going to do this a lot like the last problem. Start by getting organized. Find your average displacement in the east-west direction, and then find your average displacement in the north-south direction. So here I've set up my table. Now let's go back to the problem and let's identify all of his movement. So here we have an east. So we got 15 meters east. Here we have a west, 6 meters west. And then we have a south, and then we have a 10 meters east, and then a north. So 3 of our directions are in the west-east. So 15 is positive, 6 is negative, and 8 is positive. So he has gone 19 meters in the east-west direction. Let's do the same thing for north-south. South, south, north. Negative 12, negative 8, 5. This gives us negative 15 meters. Now we can do our vector diagram. We have 15 meters south, and then we have, it looks like, positive 19. 19 meters north. Let's draw our vector. And there you have it. So we now know he's gone 24 meters. Our arrow points this way, so let's find out the exact direction. So now here's our drawing, and to get the angle, we want to assign our coordinate plane. Now, if you can visualize this in your head, good for you. It's not required to draw this. I'm just trying to give us an option that will help. Again, we had, let's see, 19 and 15. So we're going to do theta equals inverse tangent of opposite over adjacent. And that's going to give us a theta of 51.7 or 52 degrees. So right now we have 24 meters at 52 degrees, and this would be west of south, or we can write it another way. We can say that he went 24 meters at 28 degrees. Oh geez, that's not west. That's east. East of south. Or we can say south of east. Or if you want to get really fancy, so I ask, are we done with the problem? And we are not, because if you go back and look at it, it took him 20 minutes to go this displacement, and the problem is asking for his average velocity. Well, the average velocity is displacement over time. We found his displacement, and we know his time. So let's go ahead and finish this problem. So he went 24 meters in 20 minutes. So his average velocity would then be 1.2 meters per minute. And there's your answer. So at this point, you're able to work on some problems where you need to find your displacement and you need to find your average velocity. When you're done with those, then we can try doing some other ones where we can find the average velocity moved and use that in some of our other equations. So pair up, work in groups, and good luck.